Welcome back to the channel. Today, we are diving deep into one of the most fundamental and widely used welding processes in the world: shielded metal arc welding, commonly known as SMAW or stick welding. Whether you're a beginner looking to learn welding or a professional wanting to refresh your knowledge, this comprehensive guide will cover everything you need to know about this versatile welding technique. By the end of this video, you'll understand how SMAW works, the equipment you need, safety considerations, techniques, and common applications. So grab your welding helmet, and let's get started. So, what exactly is shielded metal arc welding? SMAW is a manual arc welding process that uses a consumable electrode covered with a flux coating to lay the weld. The process was invented in the early 1900s and has become one of the most popular welding methods worldwide. The name, shielded metal arc welding, tells us a lot about the process. Shielded refers to the protective gas shield created by the decomposing flux. Metal refers to the metal electrode that melts to form the weld. And arc refers to the electric arc that generates the heat needed for welding. You might also hear this process called stick welding because the electrode looks like a stick, or manual metal arc welding, or MMA welding in some countries. The beauty of SMAW is its simplicity and versatility. It can be used in all positions, works on various metals, and can even be used outdoors in windy conditions where other processes would struggle. Let's break down the science of how this process actually works. When you strike an arc between the electrode and the base metal, electricity flows through the circuit, creating intense heat, typically between 6,000 to 10,000 degrees Fahrenheit. This extreme heat melts both the electrode and the base metal, creating a molten weld pool. But here's where it gets interesting: the flux coating on the electrode plays multiple critical roles. As it heats up, the flux coating does three important things. First, it decomposes and produces a protective gas shield that surrounds the weld area, preventing atmospheric contamination from oxygen and nitrogen. Second, it creates a slag layer that floats on top of the molten weld pool, providing additional protection and helping to shape the bead. Third, it contains deoxidizers and arc stabilizers that improve weld quality. As you move the electrode along the joint, the metal from the electrode is transferred to the workpiece, the flux creates slag, and you're left with a solid weld bead once everything cools down. The slag must be chipped off after welding to reveal the finished weld underneath. Now let's talk about the equipment you'll need for SMAW. The heart of any stick welding setup is the power source or welding machine. SMAW machines come in two main types: transformer-based machines and inverter-based machines. Modern inverter welders are lighter, more portable, and more energy efficient, while traditional transformer machines are extremely durable and reliable. Your machine needs to provide direct current DC or alternating current AC depending on your application. Most modern machines offer both. Next, you'll need electrode holders, also called stingers. This is what grips your electrode and delivers current to it. You'll also need a ground clamp to complete the electrical circuit. The electrodes themselves come in various types and sizes, which we'll discuss in detail later. For safety equipment, and this is absolutely non-negotiable, you need a proper welding helmet with the correct shade of lens, typically shade 10 to 14 for SMAW. You'll need leather welding gloves to protect your hands from heat, sparks, and radiation. Wear flame-resistant clothing, preferably leather or heavy cotton. Steel-toed boots are essential. And don't forget about respiratory protection if you're working in enclosed spaces. Additional tools include a chipping hammer to remove slag, a wire brush for cleaning, and clamps or magnets to hold your workpieces in position. Let's dive into one of the most important aspects of SMAW: understanding electrodes. Electrodes are classified using a standardized numbering system that tells you everything you need to know. Let's decode this using the most common electrode, the E6013, as an example. The A stands for electrode. The first two digits 60 indicate the minimum tensile strength in thousands of psi. So 60 means 60,000 psi tensile strength. The third digit indicates the welding positions the electrode can be used in. 1 means all positions, 2 means flat and horizontal only. The fourth digit tells you about the flux coating type and current. For example, A6010 electrodes have a cellulose-based coating and use DC positive. They provide deep penetration and are excellent for pipe welding and dirty or rusty metal. E6011 is similar but can use AC or DC. E6013 has a rutile-based coating, produces a smooth, stable arc, and is great for beginners. It works in all positions and on AC or DC. A7018 is a low-hydrogen electrode that produces high-quality welds with excellent mechanical properties. It's commonly required for structural welding and pressure vessels. The coating must be kept dry. Moisture will ruin these electrodes. A7024 is for high-speed production welding in flat or horizontal positions. The rule of thumb for electrode diameter is, thicker metal requires larger diameter electrodes. For general-purpose work, 1/8 inch or 3.2 mm electrodes are most common. Before we strike our first arc, we absolutely must talk about safety. Welding presents multiple serious hazards that demand respect and proper precautions. First, arc radiation. The welding arc produces intense ultraviolet and infrared radiation that can cause arc eye or welders flash, a painful condition similar to sunburn on your corneas. Always use a properly rated helmet, even for quick tack welds. Never look at someone else's arc without protection. Second, fumes and gases. Welding produces toxic fumes containing metal oxides that can cause serious respiratory problems. Always weld in well-ventilated areas. Use local exhaust ventilation or wear a respirator when needed, especially in confined spaces. Third, electric shock. Welding machines use high current. Never touch the electrode or metal parts of the electrode holder with bare skin or wet clothing. Turn off your machine when changing electrodes. Fourth, fire and explosion hazards. Sparks and hot metal can travel 35 feet or more. Remove all flammable materials from your work area. Have a fire extinguisher readily available. Never weld near flammable liquids or gases. Fifth, burns. The arc, molten metal, and recently welded parts are extremely hot. Hot metal doesn't look hot. Wear proper protective clothing and gloves. Use pliers, never your hands, to handle hot materials. Remember, safety isn't just about following rules, it's about going home healthy at the end of the day. Take it seriously. Let's set up your machine properly. First, determine your material thickness and electrode type. For our example, we'll use 1/4 inch mild steel with an E6013 electrode. Amperage is the most critical setting in SMAW. Here's a simple rule: use about 40 amps per 1/32 inch of electrode diameter. So for a 1/8 inch or 4/34 inch electrode, start around 160 amps. But this is just a starting point. Too low amperage causes poor penetration, stubbing, and difficulty maintaining an arc. The electrode sticks to the workpiece frequently. The weld bead will be narrow and poorly shaped with incomplete fusion. Too high amperage causes excessive spatter, electrode overheating, undercutting at the weld edges, and burn through on thin materials. For polarity, most electrodes specify either DC positive, also called reverse polarity DC negative, or AC. DC positive means the electrode is connected to the positive terminal and provides deeper penetration. About 70% of the heat goes into the workpiece. This is used for most electrodes including A7018. DC negative means the electrode is connected to the negative terminal. About 70% of heat goes into the electrode, causing faster melting. This provides less penetration and is used for thin materials in certain electrode types like E6010. AC alternates between positive and negative, providing balanced heat distribution. It's good for general purpose work and can help with arc blow issues on magnetic materials. Always consult your electrode packaging for the manufacturer's recommendations. Now for the moment of truth: striking your first arc. There are two main techniques, the scratch start and the tap start. For the scratch start, drag the electrode across the workpiece like striking a match. As soon as you see the arc, lift the electrode to your arc length. For tap start, quickly tap the electrode straight down onto the workpiece and immediately lift up. Both methods work, so use whichever feels more natural. Arc length is critical, it's the distance between the electrode tip and the workpiece. A good rule is to maintain an arc length approximately equal to the diameter of the electrode core. For 1/8 inch electrode, that's about 1/8 inch arc length. Too short an arc causes the electrode to stick and produces a narrow, tall bead. Too long an arc causes excessive spatter, poor penetration, and wide, irregular beads. Now, let's talk about the three components of good welding technique. First, travel angle. This is the angle along the direction of travel. For flat position, hold the electrode at 5 to 15 degrees from vertical, leaning in the direction of travel. This is called a drag angle or push angle depending on whether you are dragging or pushing. Second, work angle. This is the angle across the joint. For a T-joint or fillet weld, aim for 45 degrees to each surface. For a butt joint, hold the electrode perpendicular at 90 degrees. Third, travel speed. Move steadily at a speed that produces a weld bead width about 2 to 3 times the electrode core diameter. Too fast creates a narrow, uneven bead with poor fusion. Too slow causes excessive buildup and potential burn-through. Listen to your arc. A good arc sounds like bacon frying, with a steady, crisp sizzle. SMAW can be performed in 4 basic positions, each with its own challenges. First, flat position. This is the easiest position where the work surface is horizontal and you weld from above. Gravity helps hold the molten pool in place. Use a slight drag angle and steady travel speed. Second, horizontal position. The weld axis is horizontal but the weld face is vertical, like welding a horizontal seam on a wall. Gravity wants to pull the molten metal down, so you need to use a slightly faster travel speed and careful manipulation. Angle your electrode up about 5 to 10 degrees to counteract gravity. Third, vertical position. Welding straight up or down on a vertical surface. For vertical up, use a slight weave or upward triangle motion, allowing the shelf of slag below to support the molten pool. Move fast enough to stay ahead of the slag. Vertical up produces better penetration and is preferred for structural work. Vertical down is faster but provides less penetration, suitable only for thin materials. Fourth, overhead position. The most challenging position where you weld from underneath looking up. The molten metal wants to fall due to gravity. Use a smaller electrode, lower amperage, fast travel speed, and keep a short arc length. Proper electrode selection is crucial. Make sure your electrode is rated for the position you're welding in. Let's look at the 5 basic weld joint types used in SMAW. First, the butt joint. This is where 2 pieces of metal are placed edge to edge in the same plane. Butt joints can be square but for thin materials or have various edge preparations like V-groove, U-groove, or bevel for thicker materials. These groove preparations ensure full penetration through the thickness. Second, the corner joint where 2 pieces meet at approximately 90 degrees, forming an L shape. These are commonly used in box and tank fabrication. Third, the T-joint. 1 piece is perpendicular to another, forming a T-shape. This requires a fillet weld on one or both sides. The challenge here is achieving proper fusion into both members while maintaining the correct leg sizes. Fourth, the lap joint where 2 pieces overlap each other. This is simple to prepare and weld but not as strong as other joint types for structural applications. Fifth, the edge joint where 2 pieces are placed parallel with edges touching, forming a shallow groove. This is mainly used for sheet metal work. Each joint type can have different weld types applied to it. The most common are fillet welds, triangular cross-section welds used for T and lap joints, and groove welds where you fill a prepared groove in butt, corner, or edge joints. Proper joint preparation, fit up, and gap tolerance are critical for quality welds. Even experienced welders encounter problems. Let's identify common defects and how to fix them. Porosity appears as small holes or cavities in the weld metal, caused by gas trapped during solidification. Causes include contaminated base metal, moisture in the electrode coating, too long an arc length, or inadequate shielding. Solutions: clean the base metal thoroughly, use dry electrodes, maintain proper arc length, and check for drafts disrupting the gas shield. Undercut is a groove melted into the base metal at the toe of the weld. It's caused by excessive amperage, improper electrode angle, or too fast travel speed. Reduce your amperage, adjust your work angle, and slow down slightly. Overlap or cold lap occurs when the weld metal rolls over the base metal surface without fusion. This indicates insufficient heat. Increase amperage, slow travel speed, or improve your technique. Slag inclusions are non-metallic solid materials trapped in the weld metal. They result from improper cleaning between passes, incorrect electrode manipulation, or welding over heavy mill scale. Always remove all slag between passes and clean the base metal before welding. Lack of fusion means the weld metal hasn't properly fused with the base metal or previous weld bead. Causes include insufficient amperage, improper joint preparation, or poor electrode manipulation. Increase heat input and ensure proper electrode angles. Cracks are the most serious defect, linear fractures in the weld or heat-affected zone. They can be hot cracks occurring during solidification or cold cracks that form after cooling. Causes include high carbon content, rapid cooling, high restraint, or hydrogen contamination. Use proper preheat for high carbon steels, use low hydrogen electrodes where specified, and avoid overwelding. Excessive spatter indicates too high amperage, too long arc length, or improper polarity. Reduce amperage, shorten arc, and verify polarity settings. SMAW's versatility makes it invaluable across countless industries. In construction and structural steel work, SMAW is the primary process for connecting steel beams, columns, and reinforcing bar on building sites. Its portability and ability to work outdoors in windy conditions make it ideal for field work. In pipeline construction, especially oil and gas pipelines, SMAW with E6010 or E7010 electrodes is standard for root passes because of their deep penetration capabilities. Shipbuilding and marine fabrication rely heavily on SMAW for both new construction and repairs, particularly because it works well on thicker sections of steel. The maintenance and repair industry uses SMAW extensively because of its simplicity and minimal equipment requirements. You can fix broken farm equipment, repair truck frames, or maintain industrial machinery with just a small portable welder. Manufacturing facilities use SMAW for medium to heavy fabrication work, especially for one-off or small production runs where the setup simplicity is advantageous. Railroad maintenance crews use SMAW for track repair and maintenance. The aerospace and power generation industries use special electrodes for welding high-strength alloys and stainless steels. Even underwater welding uses specialized SMAW techniques with waterproof electrode coatings. The key advantages that make SMAW so popular are: equipment is relatively inexpensive and portable, minimal gas shielding issues make outdoor work feasible, it works on various material thicknesses and types, and the skills, once learned, are applicable worldwide as it's a universal process. If you're just starting with SMAW, here are my top tips for success. Start with the right electrode. E6013 is the most forgiving for beginners. It has a stable arc, produces minimal spatter, and works in all positions. Get your amperage right from the beginning. Start with the formula we discussed: 40 amps per 1 by 32 inch of electrode diameter, then adjust based on performance. Keep a consistent arc length. Think 1 electrode diameter, and maintain it throughout. This is probably the hardest skill to develop but also the most important. Practice on scrap metal first. Lots of it. Run beads on flat plate until you can make consistent, even beads. Then practice in different positions. Don't rush to weld critical projects. Clean everything thoroughly. Use a wire brush or grinder to remove mill scale, rust, paint, and any contamination. Clean welds start with clean metal. Watch your puddle, not the arc. Focus on the trailing edge of the molten pool and its behavior. This tells you everything about your travel speed and heat input. Develop a comfortable, stable body position. Welding requires steady hands. Tuck your elbows, rest your arms on the workbench, or use supports to stabilize yourself. Listen to the arc. A good arc has a distinct, consistent sound. Learn to recognize when it sounds right. Remove all slag between passes when making multi-pass welds. Even small amounts of trapped slag create defects. Be patient with yourself. Welding is a skill that takes time to develop. Everyone's first welds are terrible. Keep practicing, and you'll see steady improvement. Finally, invest in quality safety equipment from day one. Your eyes and lungs are irreplaceable. Proper maintenance keeps your SMAW equipment running reliably for years. For your welding machine, keep it clean and dry. Dust and metal particles can accumulate inside, especially in the cooling vents. Use compressed air to blow out the interior regularly with the machine unplugged, of course. Check all electrical connections periodically for tightness and corrosion. Loose connections cause poor performance and can be dangerous. Inspect cables for damage. Welding cables take abuse, they get run over, stepped on, and exposed to sparks. Replace damaged cables immediately. Damaged insulation can cause shock hazards. The electrode holder needs attention too. The jaws that grip the electrode wear over time. If your electrode slips or doesn't make good electrical contact, replace the jaws or the entire holder. Keep the holder's cable connection tight. Ground clamps also wear. The spring mechanism weakens, and the contact surfaces get covered with spatter and oxidation. Clean the contact surfaces regularly and replace worn clamps. They're inexpensive but critical for good arc performance. Electrode storage is crucial, especially for low hydrogen electrodes like E7018. These must be stored in a heated rod oven at 250 to 300 degrees Fahrenheit. If they absorb moisture, they'll cause porosity and potential cracking. Other electrode types should be stored in a dry location. If electrodes do get damp, some types can be reconditioned by baking at specific temperatures. Check the manufacturer's recommendations. Finally, keep your work area organized. A cluttered workspace is inefficient and dangerous. Have dedicated storage for electrodes, tools, and safety equipment. Clean up regularly, properly disposing of slag and metal scrap. And there you have it, a comprehensive guide to shielded metal arc welding. Let's quickly recap what we've covered. We explored what SMAW is and the science behind how it works, using an electric arc, consumable electrodes, and flux-based shielding. We discussed all the essential equipment you need and how to choose and understand welding electrodes using the classification system. We covered critical safety considerations because your safety is paramount. We went through proper machine setup, amperage selection, and polarity. We demonstrated arc striking techniques and the fundamental skills of maintaining arc length, travel angle, and speed. We covered all 4 welding positions and the 5 basic joint types. We identified common defects and how to troubleshoot them. We explored the wide range of practical applications where SMAW excels. And we shared tips for beginners and maintenance practices to keep your equipment in top shape. SMAW is truly a foundational welding process. Master it, and you'll have a valuable skill that's in demand worldwide, across countless industries. Whether you're looking to start a career in welding, work on DIY projects, or just expand your skill set, stick welding is an excellent choice. Remember, becoming proficient takes practice. Don't get discouraged by early failures. Every professional welder started exactly where you are now. If you found this video helpful, please give it a thumbs up and subscribe to the channel for more welding tutorials, tips, and techniques. Drop a comment below and let me know, are you a beginner just starting out, or an experienced welder? What aspect of SMAW do you find most challenging? I'd love to hear from you. If you want to dive deeper, check out the links in the description for electrode specifications, safety equipment recommendations, and additional resources. Thanks for watching, stay safe, and I'll see you in the next video. Now get out there and strike some arcs.